I'm going to do this in the format I'll be delivering it at CodeStock. So anyway, let's get rolling here. So first thing we're going to do is make sure that, I hate it when I go to a conference and I sit and talk for 20 minutes and realize that I have absolutely no interest whatsoever in what's going on. So I want to talk a little bit about what this talk is going to be and what it's not. So this is going to be a very brief introduction to cloud services. We are using Microsoft Azure as our example, but the concepts we cover can be used just as well in Amazon Web Services, DigitalOcean, or any number of the other cloud service providers. This is going to be very basic and conceptual. We are going to look at a few examples, have a couple demos, but this is not at all an explanation of how you should use it in your specific business. This is not an advertisement for Azure. Microsoft's not standing behind me throwing money into my pocket. I really wish they were. And this is not about how to concrete implementation details. While there's going to be some examples we cover, and you're going to see how we throw up these various instances, this is not meant for you to replicate this for your personal site. If you want to implement the services on your own, you're going to have to do a little bit of homework before you'll be ready for that. This is also not legal, medical, financial, or any other advice. If the swelling persists, please see your doctor. Okay, so about me. I am a web developer here at Radio Systems Corporation. I've been here for just, about 2.5 years, a little under 3. I work on two of our main web properties, our PetSafe and SportDog, and 2 on the outside there. We also own Invisible Fence, which you may have heard of at some point. I am also, surprise, surprise, one of the organizers of Knox PHP. I'm sure you guys have seen me somewhere before. And a little bit of trivia about myself, I am also an emergency medical responder on the Blount County Rescue Squad. I have a medical license, they let me drive an emergency truck on the weekends, it's quite an adventure. Anyway, so let's get rolling. So, knowing your ass from a hole in the ground. So let's talk about cloud infrastructure for a moment. Now, a lot of times when people talk about the various cloud infrastructure concepts, they reference a pyramid. There's 2 ways this pyramid is sometimes organized. Sometimes we have SaaS as the pointy end, sometimes we have it as the big fat wide end. I've chosen to organize it in this case as to how much work is, how much of the management you are responsible for. The other way of looking at it is how much the service you're subscribing to is responsible for. But you can see as we move towards the top of the pyramid, you're responsible for less and less of the work. So let's take a look at SaaS for a minute. So SaaS is software as a service. Now with software as a service, you're purchasing a subscription to a piece of software. This could be something like Office 365, Google Docs, Salesforce, any number of applications. The basic premise of software as a service, though, is that the software provider is responsible for all of the administration details. You do the stuff that's important to your business. You manage the portions of the administration that pertain directly to your business's domain. But everything else, all of the IT, all of the software management, server administration, updates, virus protection, firewall, supplying power to the building, everything else is provided by the service provider. So next up we have platform as a service. Now with platform as a service, it's slightly less work on the provider's part. In platform as a service, you are providing the software. Now this means that basically they're going to sell you a subscription to their platform. This may be Internet Information Services, this may be Linux running Apache, but the point is it doesn't matter to you, because all you're going to do is hand them your software in a pretty little package and they're going to host it for you. They're going to handle all of the details of implementation. You're responsible for only your software. This comes at the cost of having absolutely no access to the underlying machine though. So when running a PaaS instance, you're not going to be in there and making updates to Apache modules. You're not going to be installing software other than what you hand them. Now, containers as a service is a little bit more complicated. We can, and we actually have had entire talks on containers, and there will be more talks on containers in the future. But if you're not familiar with a container is a small, single-service virtual machine. It does one thing, and it does it well. And containers are usually partnered up together. So, for instance, if we were hosting a website on a containerized system, we would have one container running our Apache or Nginx instance. We would have another one running our PHP. We may have another one running our database. And any other services we run associated with that website would run in their own separate containers. These containers run on a dedicated container-aware VM in a cloud service provider. Conceptually, they're kind of a platform infrastructure hybrid. They're kind of infrastructure-y, but they exist in code. You can script them, but it's very strange. But we'll get into that in a minute. And then finally, we have infrastructure as a service. Now, with infrastructure as a service, it's very similar to what your IT department may already be doing, where you have a hypervisor and you have virtual machines that fire up on that hypervisor. It's pretty much the same concept. In this case, Azure is going to be running the hypervisor on the back end, and their web portal is the front end to it. You interact with that web portal or with the scripting libraries as may be to spin up and manage virtual machines. Now this is a full virtual machine, so you have complete control over the system. If you want to log in as root and start trashing system stuff, you can. If you're on a Windows virtual machine, you want to log in as administrator and start downloading every virus in the site just to see what happens, go for it, they don't care. So anyway, that's really dry and boring. So let's keep it a little more topical and let's make a pizza. Maybe. Put some work on it too. I didn't expect that pause to happen. I didn't know there was sound in here. So when making our own pizza, there's a few things you have to think about. So what goes into a pizza, right? We've got our basic ingredients, we've got our toppings, we've got ways to cook it, you know, delivery, and as you start thinking about all the things that are involved with cooking a pizza, eventually if you start expanding your view enough, it starts getting pretty stupid. That's right. Let's clean up a bit. So, when we make our own pizza, we have to worry about all of the different things that go into creating a pizza. We have to worry about our basic ingredients, our dough, our tomatoes, our cheese. We have to worry about our toppings, and I don't care what you say, pineapple is a topping. I'm firmly in pineapple. We have to worry about transporting that pizza from the bakery to the house. We have to worry about how that pizza is cooked, and there's a reason I organized it this way, but I can't remember what it is. And then we have to present it. We have to worry about drinks. We have to worry about what table we put it on, ice cream with it, whatever. But I'm feeling kind of lazy right now. I didn't get a chance to go to the store, so let's get a take and bake from Papa Murphy's down the street here. So with a take and bake pizza, we no longer have to deal with our basic ingredients. We don't have to worry about our toppings. All we have to do is go pick the pizza up, we cook it, and we put it on the table. But you know, I'm at the office, it's 7:10, I don't really have a way to cook the pizza. Let's just go pick it up. So now they're cooking the pizza for us. We are still responsible for transporting that pizza, and we're still responsible for presenting it. But I can't really, I mean, it's 7:11 now, and I mean, we got to get this talk done. So I don't really have time to go pick up the pizza, so let's have them deliver it. And in fact, you know what, let's just screw it, and we'll just go pick up the pizza. Or we'll go eat it there after the talk. We'll all go out for pizza. Now, I'm nattering on about pizza for no particular reason, but there actually does compare to what we're talking about. So if we're looking at this as a metaphor for the different cloud service paradigms, making our own pizza is very similar to the traditional on-premise structure. This is where we have our IT department, they buy hardware, they put that hardware in a server closet, the IT department manages, the IT department changes it out when it fails, they're our call center, they're everything. Getting a take and bake is like infrastructure as a service. The service provider, in this case Azure, is providing the absolute bare essentials for running a machine. They're putting power in the building, they're making sure we have a network connection, and they're giving us access to their hypervisor so we can spin up virtual machines as we need, but their involvement ends at that point. So letting them cook it is similar to containers as a service. There's a little bit more work happening on our end, but there's still a lot of it that's happening outside of our direct control. Ordering for delivery would be like platform as a service. The service is handling all of the details of delivery, we're just handling the final product at the very end. And then going eating out is like software as a service, where everything is provided for us, we just eat pizza and then give them our credit card. So let's take a look at pizza as a service. So you can see here on this chart, as we move towards the right, we're moving more from the traditional on-premise towards the software as a service paradigm. And you can see if you look in the blue, we have what you're responsible for managing, whereas in the orange, we have what the vendor manages. And as you move further to the right, further away from traditional and more towards the software as a service paradigm, you see the vendor is taking on more and more of the responsibility. Until you get to software as a service where they are providing everything and you're just writing a check. So let's talk about software as a service for a minute. So with software as a service, your vendor is handling all of the details of the infrastructure, server, and administration of the software. And you're basically, you write them a check, they give you a service. You're purchasing a product, and you are a consumer. IT doesn't have to get involved. Basically, it's between you, accounting, and whoever your production people are. The end user doesn't need to know anything whatsoever about the platform. There's not a whole lot to say about software as a service because it's actually a pretty straightforward thing. So let's take a look at that. Now, the way I did my demos here, I've been to CodeStock twice, and one of those years, the internet connection was a little bit spotty. So I pre-recorded my demos here. So we're going to go through that, and I'm going to narrate it as if I'm doing them live. So I'm going to stand here, and I'm going to pretend I'm doing it, but it's pre-recorded. But at any rate, I did that for two reasons. Partially because of the possibility of internet trouble, and also because some of this involves some cook time. As you'll see when we get into it, there's some parts that I skip through pretty quickly because it's sitting and staring at progress bar for 10 minutes. And that's not any fun. Nobody wants to see me say show tunes for 10 minutes. So let's get started here. So here we have the Azure Web Portal. We're going to come over here to the Add button, and we're going to fire up a WordPress instance. So let's come down here. We're going to pick WordPress, and then we're going to click Create. So what it's going to do here is it's going to ask us a couple questions. We're going to name our app, and this has to be globally unique. So we share this namespace with everyone else who's on Azure. So in this particular case, I'm prefixing it with something that no one else is going to use. We create a resource group to keep our system organized. Now, in SaaS, the resource group doesn't matter as much, but when we get into some of the other paradigms later, you can see sometimes there's a bunch of resources that get tied together. So here we're going to click Create, and now we're going to accelerate time. 1 minute and 42 seconds later, it's the quickest minute 42 ever, we're ready to go with our back end. Now, you see right here, we can come, well, let's let that load for a minute. So now, once that's loaded, we can come right up here to the URL, we can click it, and there's our WordPress instance running. That's it. We didn't have to futz about with servers, we didn't have to do any configuration, we told it what we wanted, and it's delivered. So let's fire up a website for Joe's Pizza Shack real quick. Joey C's starting up a new pizza restaurant, and he wants to throw up a WordPress site for him. Let's go ahead and get this backend registered. CodeStock 2017 at rescuecoder.com. And we're going to go ahead and disable the search engine visibility because this is just a demo. We don't want people actually thinking we run a pizza joint. Let's go ahead and log into the backend here. And see, this is a fully functional WordPress site that we've spun up in less than 2 minutes. So we log into the backend here. You can see right here everything you would expect from a WordPress site. Let's close that out. And we can come over here. We can look around, look at our posts. We can come down. Let's make some changes real quick. So let's go to, let's take a look at the site. So here's our nice modern art website with the default WordPress template. Let's go back to the admin console. Let's make a change to it real quick. We'll go, no, we don't want pages. Let's go down to the appearance. Let's customize that template a little bit. We'll talk about what Joe's Pizza Shack actually does. Let's go to site identity, tagline, we make pizza and stuff. We'll go ahead and save that. This is the part where I sing show tunes.
Can't hear you. Do it louder.
You don't actually want me to sing show tunes, I promise.
Oh, but I do.
And there it is. Well, once we reload, there it is. So you see, in 1 minute, what was it, 1 minute and 36 seconds, we spun up a WordPress site from non-existent to able to accept traffic. So let's go ahead and close out. Now, when we do a demo, I don't like leaving a mess laying around, so we're going to go ahead and clean this up. So let's switch back over. All right, we didn't close that. Let's switch back over to our Azure console. Now let's go ahead and delete this machine. Oh, you can see here we got our traffic there where we hit the website. Let's go ahead and delete this machine and clean up after ourselves. So we'll go ahead and delete the app. And there we go. In under 3 minutes, we have built and torn down a WordPress site. Go ahead and delete this and demo. Delete that resource group. And that's SaaS. So you see, there was no administration we had to do at all. We went into the Azure portal, we told it what we wanted, we did some basic, like this is what our website should be called, this is where I want it to sit, and then we had a website. And that's as simple as SaaS is. Okay, so that's enough about that. Let's move on to platform. So platform as a service is a little bit more to talk about. So with platform as a service, you provide the software and your service provider is going to handle everything else. I say that this is ideal for web apps, and in fact Azure refers to platform as a service as a web app, but it's not limited to just web applications. If you want to run anything that has a server model, you can do that. There's a lot of features for things that aren't necessarily exposed to the public. Just off the top of my head, you can run automated tasks, you can run databases in it, there's any number of things that you can do. The key benefit of this is it allows you to focus on development and not administration. Now, we're all developers here, primarily. I'm sure some of us have some admin work, but we're definitely not an IT department. We're not really, I wouldn't say that I'm, at this point, I've been out of IT for about 4 or 5 years now. I wouldn't say I'm qualified to run servers anymore, like as the primary IT director. So this allows us to let somebody who knows much more about it handle that. They can handle the operating system administration, they can handle the antivirus, the firewall. All we do is provide the basic software. So I hate reading from slides, but I'm going to do it just this once, and that's a lie, because I'm going to do it 2 more times in this talk. So the primary advantage of the PaaS system is that all OS updates, backups, security management, and server administration are left in the hands of people more qualified to handle them. Zero-day exploits and other security issues are handled automatically by the cloud provider's staff. This means that you focus on what you're good at, they'll focus on what they're good at, and everybody's happy. So let's take a look at a demo. This is the same kind of paradigm. We're going to be taking a look at a pre-recorded live demo. So just like before, we're back in our Azure portal. We're going to fire up a new instance. We're going to pull up a web app. So once we have our web app, I'm going to click web app here, and I click create. And you'll see this time it wants a little bit more information from us. So we're going to give our app a name. Again, this is a globally unique name, so we have to make sure we don't collide with any other Azure user. We can go ahead and create a resource group. I'll pin that to the dashboard, and we'll create. Let's accelerate time, 23 seconds. In 23 seconds, we have our platform set up. Now, you may be wondering, we've got our platform set up, but we haven't actually told it what to do yet. So how do we do that? Well, there's a number of ways that you can get your code in here, but the way I like to do it is with Git. We're actually going to set up a local Git repository on our PaaS instance, and we're going to attach to that with Git remote. So you see right here, we've got our Git clone URL, we've got a username. Let's go ahead and set up our credentials. So let's set our Git username and password. We're going to type in our super secret password right here that I can never tell you. It's some password 123, by the way. And we're going to go ahead and save, and it is complaining. And that's because I didn't change the username. I had actually rehearsed this video before I recorded it, and I ended up with a username collision. So we're just going to set something different here. Go ahead and save that. So now our deployment credentials are set. We come back over here to the overview. You see on the top right, we have our new Git username, and we have a Git clone URL. So let's go ahead and switch over to our IDE. Now this is a blank PHP project I started. There's absolutely no pre-configuration on it. So we're going to create a new index.php file. We're just going to do something simple, like let's just dump PHP info. And let's get rid of that blank line because it annoys me, and I hate it. We're going to go ahead and save that file, and come down here to the terminal. And we're going to initialize a new Git project. So let's do a git init. And then let's go ahead and add that Git clone URL as a remote. And then let's go ahead and add the current directory to our Git project. Go ahead and make our initial commit. And then let's go ahead and deploy that. So we're just going to deploy it by just pushing to Azure Master. So let's type our super secret password that no one knows. And away we roll. Eventually. There we go. So you can see down here, we're just doing a normal git push to remote. And as it gets down, you notice deployment successful. So let's switch back over to our other screen, and we're going to open that URL in a new tab. And there it is. Now notice at the top, we're running PHP version 5.6. And this is one of the points I wanted to bring up with Platform as a Service, is that it's extremely powerful and easy to make changes to. So let's come down here to Application Settings. 5.6 isn't going to cut it anymore. Let's upgrade to 7.0. So we're going to select PHP 7, hit save, wait for that to update, switch back over to our other window and reload. And look at that. With just a couple clicks, we've updated from PHP 5.6 to PHP 7.0. And this kind of demonstrates some of the power of Platform as a Service. Now, there's a lot this is just a very brief skim the surface of it. There's a lot more features that Platform as a Service has, and we'll go into a few of those at the very end. But for now, let's just go ahead and clean up our mess so we can get ready to take a look at containers. So we're going to just copy pasta this, paste, and delete. I don't like leaving a mess behind me. And there we go, all nice and clean. That'll go away up there. Okay, so you see what Platform can do. Now, with Platform as a Service, it's very powerful. It is worth keeping in mind, though, that you don't control the platform itself other than some basic configuration options. So in the case of Azure, it actually runs Microsoft Internet Information Services on Windows as its platform. Now, I've heard people tell me that they've recently added support for Linux and Apache, or possibly Nginx, but I haven't played with that yet. So its existence is a rumor to me. But that is worth keeping in mind. So if you have an application that's very platform specific, you may need to look at something like infrastructure as a service in order to get it running properly. But let's talk about containers. So going back to our pyramid here, we have containers as a service. Now, we've already explored containers very briefly. Containers are small single-service virtual machines. Now, Azure in particular uses Docker containers, and there's different ways it handles this. There's different paradigms you can do for managing your Docker containers, but we're going to take a look at Azure Container Service. So in this particular case, we have Docker running on an abstracted infrastructure as a service server. The Docker containers can be swarmed. So if we want to use Docker Swarm or Kubernetes or ECLS or any of the other container swarming systems, Azure supports that. One of the big advantages of this, I believe, though, is that you can administer your container swarms and networks from your local command line. You don't even have to be logged into the backend, into the Azure portal once you get your system set up. So this containers allow you to segregate your services into scalable, replicable containers, granting you the hands-off functionality and scalability of a PaaS approach, but the configurability and control of an IaaS approach. I promise I'll learn to talk eventually. It's the best of both worlds. So let's take a look at CaaS. Maybe I click the button. So just like before, we're coming into our Azure control panel. We're going to fire up a new Azure Container Service. Let's go ahead and search for containers on the little box here. And then let's pick Azure Container Service. So see, there's all kinds of other options for managing them, but we're going to take a look at ACS here. So there's a little bit more information it needs from us. So we're going to go ahead and set up our orchestrator as Swarm. Talking about the different orchestrators is beyond the scope of what we're talking about right now. So just for now, just trust me that we're using Swarm. And then we give it our resource group name, our DNS name prefix, which again has to be more or less unique if I remember right. We're going to go ahead and set up a username. So we're going to be rescue coder again. And then, oh, it's looking for a public key here. So with this Docker administration, we're actually using certificate-based authentication. So let's go ahead and get those keys generated. So let's build out our RSA key here with CaaS 17 demo. I don't want passphrase. That's clear because it annoys me. And then we'll go ahead and cap our public key and copy that to the clipboard. And switch back over to our Azure panel and paste that public key in there. Groovy. Okay, so now we're going to come into the agent configuration. We want one agent, and we're not going to deal with the virtual machine size. We'll talk about that in infrastructure. So our validation is passed. Let's click OK. And we'll accelerate time for 9 minutes and 6 seconds. This is actually the slowest deployment I did. Was deploying Azure Container Service. Now, if you take a look at our resource group, whoa, there's a bunch of stuff in there. So let's come into our Azure Container Service. I'm flying through this. I think I did it too fast. But let's go ahead and get mapped into this so we can make some changes. So we're going to open an SSH tunnel to the Docker manager, and go ahead and set an environment variable so Docker knows we're working with a remote machine. And let's go ahead and pull down a Docker image. Let's use Ghost. It's a Node.js based content management system, blogging platform. I don't care about that. So right now what we're actually doing is Azure is downloading a copy of the Ghost Docker container. That's already done, so let's go ahead and fire that up. And we're up and running. So let's switch over to the other window So we're going to copy this agent address right here. Now, the Azure Container Service includes the load balancers and all kinds of features to make this friendlier, but this is a quick demo, so we're just going to hop straight into it. And here we are, we're running Ghost. So you can see this is a full install, fully functional. We can go to our admin panel, look around. We're not going to go quite as in-depth as we did with WordPress, so just showing you that with that, we've fired up our Ghost image. Now, if we switch back over here and we run a Docker kill, let's get that container ID. Let's go ahead and Docker kill that container. And see the command run on my local machine, we switch over here to reload, and there's our Docker machine no longer available on Azure. So that's, let's go ahead and clean up after ourselves here. We should probably force that. All right, go ahead and exit the terminal, and let's go ahead and tear down our container service. So come back into the resource manager here. We'll just delete it from right here. Now, I've made it look relatively simple here, I think, but this is actually, setting up the CaaS instance on Azure was a little bit complicated. It took me the better part of the day to get it working properly. I've got to condense down to the 11 minutes that worked. Now, containers are extremely powerful. But there is a little bit more administration overhead involved in them. So if you've never worked with containers before and you're interested in running containers for your site, you're going to need to do some homework. It's way beyond the scope of what we're going to talk about here, but I highly recommend looking into them. Check out a couple tutorials online about containers. So finally, this brings us to infrastructure as a service. Now, infrastructure as a service, I believe, is the most powerful cloud service paradigm, and that's because they do the least amount of work. So infrastructure as a service, we're running a full virtual machine. This is no different than if our IT department spun up a VM on their hypervisor downstairs. It's just, in this particular case, it's running in Azure's data center. And there's any number of data centers scattered all over the world that we can run our machines in. In this particular example, we're going to be using the data center that's in the south central United States because we're in Knoxville, which is relatively south central. I think their data center is in Texas, but I'm probably completely wrong on that, so pretend I didn't say it. But at any rate, with infrastructure as a service, you can use whatever operating system you want because they're providing you virtual hardware and you're responsible for everything that goes on that virtual hardware. You can install any software you want, you can do any administration function you want, and you have full control over the VM, but it comes at a cost. And that cost is that you are responsible for all operating system and software updates, security patches, and maintenance. Unless you have a separate agreement with them for that support, the service provider is not going to provide you any support pertaining to these issues. So you're more or less on your own. This is a great example of one of those times where it's good to turn your IT department loose on it. Be like, here, set me up some VMs. So let's take a look at infrastructure as a service. So here we are back in our Azure portal again. So we're going to go up here to new, and we're going to use compute, which is where they store this stuff. So let's fire up an Ubuntu Server 1604 instance. We're going to give it our unique name. We're going to use SSDs instead of mechanical hard drives because we're baller like that. And let's give it a username for login. And I don't want to mess around with that public key nonsense anymore, so we're just going to do regular old password login. We're going to use my free trial credit that I've got. I'm going to create our new resource group, and notice at the bottom we have location. There are dozens of data centers scattered all over the planet. So there's one near you. So these are the different pricing options that Azure has. And you can see as the machines get more powerful, the options get more expensive. Now I'm on a free trial account, so some of the higher end stuff isn't available to me. They don't want to, they didn't want to front me $1,200 just on the chance that I might buy something. But we don't care about that. We're just going to run this basic BT instance. So now let's see, we can see our storage, we have our virtual network we're going to be configuring, we don't want any extensions, we don't care about availability sets. Let's go ahead and fire this puppy up. So it's going to run its basic validation here. We click OK, and then we wait for 2 minutes and 1 second. So 2 minutes, 1 second later, we have our running Ubuntu instance. So let's actually do something with that. Let's, you can see here we've got our virtual network assigned on the right there. Let's go ahead and copy this IP address. Let's SSH into it and play around for a minute. So here we'll SSH rescue coder at, and I'll paste in the IP address. Yes, that's fine, super is fine, super secret password. It's the same combination I have on my luggage, by the way. Okay, so let's get in there and take a look around. So now you see we're logged into the system, we're in the root directory. Let's log in as root, and let's do something useful. Let's create a script. Let's do nano my script. Let's have it do something really profound and useful. So we're gonna say yo. So go ahead and make that executable, and we'll drop out of root. We'll switch to a different directory. Let's run my script. You can see we've been able to perform a root function on this machine. So some fool at Microsoft is giving me root access to something. I know they're going to learn that's a mistake. So let's install Perl, which is apparently already there. So let's try something more useful. Let's install Lynx, a text-based web browser. See right here, we're installing software as if it's our own machine. Let's fire up Lynx. Let's look at ipchicken.com. I don't really care about cookies, that's fine. Allow. You can see here, 13, 66, 55, 154. This IP chicken is reporting us as connected from Azure's data center. All right, cool. So that was fun. Let's go ahead and exit this. All right, and switch back over to our admin console. So let's go ahead and stop this machine for a bit. Now, if you'll notice, I hit the stop button, and then we're going to spend some time. 2 minutes and 18 seconds later, notice that up here under status on the top left, it says deallocated. Now, when Azure only charges you for the time your machine is running. So if we stop the machine and it deallocates, we're no longer paying for that subscription. You can start that machine back up. That has a lot of applications for scripting. If you have machines that you only need to fire up under certain circumstances, you only actually have to pay for them while you're using them. Let's go ahead and start this up. But while that's starting back up, let's have a little fun. Let's fire up another virtual machine. So we're going to fire up another Ubuntu 16.04 instance. So 16.04 LTS. Click create. All the same stuff. Here's our globally unique name. It's going to be exactly the same as the other one, except we're going to put a 2 at the end because it's the SQL. SSDs because we're baller. Username. Super secret password. We're going to use our existing resource group to keep everything nice and clean. We don't care about pricing now because we've already went over all that, so let's just go ahead and grab one. You notice we're using the same virtual network, but it is getting its own IP address assigned. We don't care about extensions, let's just go ahead and create that machine. So let it run its validation, click OK. And 5 minutes and 24 seconds later, I'm not sure why this one took longer, actually, but it did. 5 minutes and 24 seconds later, we have 2 virtual machines running on our virtual network. Now, let's take a look at each of these. I'll tell you what, let's go ahead and let's SSH into, or see here we got our virtual network. Let's go ahead and SSH into these. Yes, we like to assert, super secret password. Alright, so now if we pull up our IF config, you can see we're running on 10.0.0.5 as our IP address. Let's go ahead and expand this a little bit, over to the tab, and switch back over to our portal. Let's SSH into the other machine at the same time. It'd probably help if I had that IP address, wouldn't it? Okay, so now if we IF config, if I can look at type, and take a look at where our IP address is 10.0.0.4. It's either both running on the same subnet, and in fact we can ping across as if they were physically sitting in the same room. And as exciting as that is, let's go ahead and stop. And we can SSH across if we want to. So let's SSH into the other machine. You notice a pattern here yet with the secret password? Alright, so now let's take a look around. Let's do something cool. Let's echo what's up to wall, which writes it onto all consoles. We switch over to other machines, see we were able to SSH into it and run commands on the other machine as if they were on the same network. Cool. All right, so let's go ahead and close out of this one. So you know what? This rabbit hole goes a little bit deeper. So let's go ahead. We looked at Linux servers. Let's fire up a Windows server. Does anybody still use those? So let's fire up a copy of Windows Server 2008 R2 Service Pack 1. So we're going to do the same things as before. We're going to do our unique name. We're going to have our disk type, our username and password for logging in, assign it to a subscription. We're going to assign it to a resource group to keep everything nice and organized. Pick a location, and notice at the bottom while I'm filling out this form, this option for save money. Now, if you've ever used Windows, you know that you have to pay for it, as crazy as that sounds. One option they offer is you can actually, if you have an existing server license, you can put your server license information in there and save a little bit of money on your subscription. But if you don't have a license, that's chill. They'll actually roll the cost of your license into your monthly subscription. So you're really only paying for certificate for usage that you're actually using. This is one advantage that infrastructure has over on-premise is that you only pay for what you actually use. Now see here, our V2 is a little bit more expensive because we're having to pay for that Windows licensing as well, but everything else is the same. We've got a virtual network, our assigned IP address. Let's go ahead and let it build this thing out. So 6 minutes and 36 seconds later, we have our Windows server. So let's take a look. Let's go ahead and grab this IP address up here. I don't know where I'm wandering off there. All right, let's go ahead and grab that IP address. Let's RDC into this. We're going to pull up a remote desktop connection. We're going to log in like we're going to administer this server. So I just happen to have Microsoft Remote Desktop laying around. So let's go ahead and new. Pull this over here so you can actually see it. Give it some kind of a profound name. We're going to set that IP address. We're going to mess around with the full screen mode because I was completely looking at the wrong setting. And fill in our username. Close that, and we'll connect to it. And look at that, we're connected to our virtual Windows server instance. Let's go ahead and log in. Super secret password. And here we are, we're at our desktop. So you can see in just about, 5 minutes, we've spun up a Windows server from start to finish from scratch to nothing. And if you've ever set up a Windows server from start to finish, it is not a 5-minute process. So you can see here we're on the same network, 10.0.0.6. We can ping across to our other machine. If we actually had SSH on Windows, we could sign into the other machine. They can communicate all 3 machines as though they're sitting on the same network. And in fact, they are sitting on the same virtual network. Now, these machines may not even be in the same data center. We've got 2 Linux servers and a Windows server. These could be sitting in data centers hundreds of miles apart. We put them both in South Central. I think they're in Texas, but they may not be. But Azure's going to handle all of that network for us. So they're handling powering our servers, they're handling the network communication, but we're responsible for everything else, all the other administration. So let's go ahead and tear down our instance here and clean up after ourselves. I don't know about you, but I don't want to pay $96 a month for my demo server. Now look at this, see all of this stuff in our resource group. These are all the things that are involved in managing that virtual network, and Azure created most of them for us, but we don't care, we're just going to delete it all right now. So this process of deleting these virtual machines takes a while, so we're not going to sit and watch all that. We're just going to close out of these little boxes, and we're going to go ahead and end that demo. Maybe, there we go. So you can see infrastructure as a service has its advantages, it has its disadvantages, but it is an extremely powerful paradigm. We've basically, in the span of about 15 to 20 minutes, built an entire network from the ground up, including 2 Linux servers and a Windows server, and installed our operating systems, and even went in and fussed around with them a little bit, and then tore them back down. This has a lot of advantages for systems where your demand isn't always static. We'll go into it just a little bit on the next slide, but imagine you running a website and someone on Reddit gets a hold of it, and then you get the Reddit home of death. Well, your one server just choked under the load of 30,000 people hitting it. Well, with cloud services, a lot of them, Azure, Amazon Web Services, I know supports it, I believe DigitalOcean does as well, they can actually scale on demand. So in the event we're running, say, a PaaS instance running a server, and we get the Reddit home of death, we can now spin up 5 more of them to handle that traffic, and it'll handle that automatically within the bounds that you set. Once Reddit loses interest and wanders off to the cat picture of the day, and our traffic falls below 20% on one of those machines, it will start retiring and shutting down those machines as needed until we're back down to our minimum. So let's take a look at the 2 biggest. There's IaaS and PaaS. These are our 2 biggest paradigms. So I wanted to take a look at them side by side here and go through some of the pros and cons of each of them. Now, I'm just going to go left to right, top to bottom here. But with IaaS, you have more control, but it comes with the price of responsibility. As Uncle Ben said, with great power comes great responsibility. When you run an IaaS server, you have complete control over the system, but you're responsible for everything. That's the downside, is that you have complete control over that system. Right. So with PaaS, I put Microsoft on here, but that could be Amazon Web Services, that could be DigitalOcean. They're going to handle all the maintenance administration for you. You don't have to worry about any of that. You just have to worry about running your software. The cost of this is less control. So it may be that your application needs settings on the server that just you don't have access to. Now, there's a lot of configuration options for PaaS, and it's spectacular how configurable it is, but there are some things that just won't run on it, and we ran into that a little while back with some experiments we were doing. I had an application called Sileus, which is a e-commerce platform that I worked for about 3 days and could get it running on a platform instance. So not everything's going to work with it, but it does have a lot of power. Now, IaaS, we're marginally cheaper for Linux virtual machines. But if we're running a Windows server, it could be twice the cost of PaaS or more. And that's because we have to roll that additional Windows licensing, the licensing expense in. So with PaaS, your price doesn't change by platform, but that's because you only have one platform, or possibly 2 if the things I've been told are correct. So it's very hard to vary by platform when there aren't other platforms. So with IaaS, your instance is just as configurable as you like. The downside of that is all of your configuration is handled inside your virtual machine. So in order to do that configuration, you've got to remote in, you've got to write those config files, you've got to make those changes. With PaaS, we have something called a hybrid config. Now, you can have your configuration set in your application that you upload to PaaS, but you can also set your configuration external to that, so it's in environment variables on your PaaS instance. And this is actually the way Microsoft recommends you do it when you're using the web app services. You define environment variables using their portal, and you have your application set to pull your settings from those environment variables rather than hard-coded into config files. The downside of this is hybrid config is a little bit more complex. So whereas before you knew that your configuration was in this file, it might be in this file, or it might be somewhere in the Azure portal. There's really no telling. You're going to have to go hunt for it. So with IaaS, you have complete control of your file system, but that comes at the cost of all software upgrades being completely manual. If you need to run your Windows updates, you've got to run your Windows updates. If you've got to update your software, you need to update your version of PHP, you need to update Node.js, you're doing that by hand, unless you have some kind of a magic way to do it. With PaaS, your software upgrades are done with a click. And we saw this when we upgraded from PHP 5.6 to PHP 7 with 2 or 3 mouse clicks. We didn't have to make any changes to our application whatsoever. We clicked and it was 7. This comes with the cost of limited software options. As I said before, not everything is going to run on PaaS flawlessly. That's going to be completely dependent on what platform they're running and whether your software just can handle it. So taking a look at IaaS versus PaaS, with IaaS you have a single deployment with multiple servers. This means that unless you have some kind of an automated deployment that you set up, you're taking your one deployment and you're deploying it to whatever multiple servers you're running. With PaaS, you have multiple deployment slots but a single server. As far as your administration is concerned, there is one server. The service provider is going to handle all the details of making sure you're deployed to all of them. Now, PaaS in Azure has something known as deployment slots. I didn't cover this in the demo, but this is actually really cool. You can actually have multiple instances of your platform as a service running, and have one of them designated as your production instance, one designated as staging, development, some feature, whatever. And you can swap those instances out. So when we're ready to release a feature, we work on our feature in feature branch 1, we swap that with staging, we do our testing, we swap staging into production, the old production instance becomes staging. But we have configuration that's tied to that slot. So say we have our production database. Well, when we move our staging up to the production instance, we don't want that staging database to come with it. We want to use the actual prod database. So we can actually tie those settings to the deployment slot instead of the application itself. So the settings don't change, but the code itself does. It's a very powerful, very handy feature. So with IaaS, you're going to have to build your own deployment system if you want automated deployments. Or you can find someone else's deployment system and implement it. With PaaS, you've got multiple deployment options. You saw when we deployed our software to PaaS, we did it with a Git commit. It was very simple, only took a few seconds. A little bit more philosophical, we have the argument of servers as pets versus servers as livestock. Now, I don't know if anyone's ever heard this argument before, but it's a way of looking at your services, your servers. With servers as pets is kind of the traditional way. You have 4 servers. They all have, some kind of snazzy name that all tie together. This one's named John, this one's Harry, whatever. When something goes wrong with the server, it's the end of the world. You gotta fix it, you coddle it, you pet it, you take it to the doctor, that's your baby. With servers as livestock, if you have 4 servers, hey, that's great. There's 4 servers, remember 1 through 4. If one of them dies, go big, toss it out, put another one in. It's a very newer paradigm, it's a much newer paradigm that's deeply ingrained in the platform as a service. So with platform as a service, if we had a copy of our, let's talk about React. React is a distributed database system. If we were running React in multiple database instances, we could swarm those very easily, have 4 of them, have 5 of them. If one of them dies, no biggie, chuck one out, replace it with another instance. Right, so with IaaS, your scalability is determined by your software, which is actually a pro and a con. You're responsible for determining whether your software can scale up and scale out. We'll talk about that in a second. But the downside of that is your scalability is determined by your software. So if the software you've written isn't scalable, then it's just not scalable. That's end of sentence. With PaaS instances, they're scalable up and out. Now, scaling up means we make the system more powerful. And remember a minute ago when we were firing up our infrastructure since we picked our pricing plan. That was how powerful that server was. We had 4 cores, we're running 512 megs of RAM, whatever. Scaling up, we now have 8 cores and 4 gigs of RAM, whatever. We make our server more powerful. With scaling out, we add servers. So instead of making one server more powerful, we add 4 more servers. And this has the added advantage with PaaS is you can scale up on demand. So if we had 80% demand on us, we eat 80% of our resources, we spin up another server, we tear that server down when we no longer need it. So with IaaS, it can be managed by your IT department. They're already used to working with virtual machines. They're already used to working with hypervisors. This is just something else they can just do. And there's a small learning curve on it, but they'll be able to figure it out pretty quickly. The advantage of PaaS is you don't really need an IT department. So you can upload your application, and as long as everything works, you're golden. You don't need anyone else to manage your network. You don't need them to make sure your hard drive's up to date. You don't have up to date. Make sure your hard drive's working. You don't have to make sure you've got power in the building. All of this is handled for you. IaaS is a familiar model. So this is the way people have been working for a long time. We have our servers, we configure them, we run our software on them. There's not really a whole lot of learning involved in that. Downside to PaaS is it's a little bit of a new way of thinking and a new paradigm, and it does take a little bit of getting used to. So with PaaS, we have a very rapid spin up of our application. You see we spun up a PaaS instance in 23 seconds and deployed our application to it in, 15, 20 seconds? So in less than a minute, we had our application deployed from the time we clicked go. Now, the con of IaaS is spinning up a new VM is a lot slower. But it's still faster than running to a store, buying new hardware, installing it, installing Windows, running all your updates, putting antivirus on it, and making sure it's joined to your domain correctly. So there is still that advantage. So anyway, that's actually the conclusion of the talk.